Hello, in this video we are going to look at another couple of applications of Pythagoras in 2D. Okay, so this question, two streetlight posts are located 3 meters apart. Let me get a highlighter. So two posts 3 meters apart, an electricity wire, so a wire links the tops of the two posts. Links tops of two posts. If the posts are 3.6 meters and 4.5 meters in height, what is the length of wire required? And to one decimal place. So let's just try and draw it sentence by sentence, because Dr. Wack says we draw a diagram first, okay? Okay, two streetlight posts, 3 meters apart. Okay, 3 meters apart means this distance is 3 meters. And I think it said that the posts are different heights, okay? Just going to do that. See in that third sentence, if the posts are 3.6 meters and 4.5 meters in height. So I've used that bit information, this bit information, and it says so we can even say post 1 and post 2. You can label it. An electricity wire links the tops of the two posts. The tops of the two posts. And what is the length of the wire? So this is the wire, and we need to know what that length is. Okay. So have a look at it. Have a look at this diagram. How might we find x? How might we find x? Okay, looking at this. All right, I'm given this information for a reason. I'm given this 4.5 and 3.6 for a reason. Let's look at that. Can I find some information using that? I can. Okay, what if I drew that line in? That's key to this type of problem. Draw that line in. This is a right angle triangle. And now you look at it and we think, okay, this horizontal distance, well, it's got to be the same as this distance, 3 meters, right? So we've got that side known. We don't know x. Can we find what this side is? Well, we can. We can do it. It's the leftover of this big height and this height. So this side is going to be 4.5 take 3.6. That's the key to this problem. 4.5 take 3.6 is 0.9. Now, if that diagram is confusing, draw a little diagram off to the side, focusing on that right angle triangle. So I'm just going to focus on that triangle and what we know and simplify my life. So x is there, 3 is here, and we decided that by subtracting those vertical heights, we would get 0.9 is this distance, okay? So zoom in on that triangle. Now, just focusing on this triangle, we have information about 3 side lengths. So, and it's a right angle triangle, that means Pythagoras. And then we're going to label our side lengths. Hypotenuse is opposite the right angle. And then we've got A and B. And we'll do a quick unit check, meters and meters, good. Then we're going to substitute into our formula. So C is x squared, a squared, 3 squared, plus 0.9 squared. And with working, you want to substitute and you want to simplify on each side, okay? So x squared, that doesn't go any further. 3 squared plus 0.9 squared. And that's 9.81. And that's x squared. We want x. We need to square root both sides. Square root 9.81 is 3.1, because we want it to one decimal place, and two things to check at the end: decimal places and units. We plugged in meters, we should get out meters. So you could say, even a sentence at the end, cable is 3.1 meters long. Okay. And last question of Pythag in 2D. Let's have a read and a highlight. Okay. So, two buildings. So similar sort of problem. This is a certain type of problem. Two buildings, 35 meters apart. A cable of length 64.5 meters links the tops of the buildings. So see, with both of these problems, they're linking the tops of the posts, linking the tops of the buildings. This is the type of problem, okay? If the shorter building is 150 meters tall, what is the height of the taller building? So we're finding a slightly different thing this time. Now let's just draw it sentence by sentence. We're going to form our diagram. So if we're confronted with a word problem, we think of Dr. Whack, okay, and follow those steps. Two buildings, 35 meters apart. And we know that there's a shorter building and a taller building, okay? So let's just put that information in. They're 35 meters apart, and one's taller than the other. Let's just make it a bit different to see this time. Okay. So we've used that bit of information. Okay, and a cable of length 64.5 meters links the tops of the building. The tops are linked by this. If the shorter building, okay, this is the shorter building, is 150 meters tall, what is the height of the taller building? Height of the taller building, we don't know it. Okay. Looking at this, looks a bit scary, but our key, okay, with these, if you've got this weird quadrilateral shape, you want to just draw in this line straight away, because these horizontal lengths are the same. Okay? It's how far apart they are. So this is 35. This must also be 35, okay? Then, what else have we got? I'm going to put a right angle there. So, what is the height of the taller building? So our goal is to find this full height. How can we do that? All right, that full height, let's highlight these in something. Whoops. That full height is going to be this height plus this height. Would you agree? This full distance is going to be the sum of these two distances. So what can we do? Let's actually call this, what can we do? We'll go, this distance is going to be, let's call it y. And then we can say something like to ourselves, x is going to be, so this full distance is going to be y plus 150. Y plus 150. Okay, pause the video and have a break if you need, okay? So how can I find that y? Well, I can draw a little diagram off to the side of this right angle triangle. I'm going to draw a little right angle triangle off to the side. So I'm going to be fatigued. Okay. So draw this, zoom in on it. We've got 64.5, we've got 35, and we don't know, we're calling it y. Okay. Now, diagram, rule. We've got 3 side lengths involved, so we're going to use Pythagoras. Now go back and label your diagram with C, A, and B. C, A, B. 64.5 squared, 35 squared plus y squared. And simplify on each side. So 64.5 squared, 4160.25. And 35 squared, 1225. Now I've got this. I'm going to remove what's furthest away from that y term, okay? It's the 1225. So I'm going to subtract 1225 from both sides. That's going to cancel there. We'll be left with y squared. 4160.25, take 1225 is 2935.25. And we've got y squared. We need to square root both sides to get y on its own. So keep that answer in your calculator. Say root answer. And in meters to 1 decimal place. Well, we plugged in meters. We should get out meters. Oh, actually, 1 second. We need to keep our answer in there. This is our plan. Once we find this distance y, we're going to plug it back into here, remember, because we need the height of the taller building, this full height. So we need to add that 150 on, okay? So, but for now, we have found y. Y is 54 point, just keep it to a few decimal places till the very end, okay? Okay, and then, therefore, x equals y plus 150 equals 54.178 plus 150. And in my calculator, the height of the building should be 204. And two things to check at the end, units and decimal places. So how many decimal places was it? 1 decimal place. So 204.2 meters is how tall that building. And you might just want to check your answer makes sense. So the shorter building should be shorter than the taller building, right? And 204 is bigger than 150, so we're all good. Okay, so I hope that made sense. The key is when you're given these weird quadrilateral type shapes, draw in that line across, separating it. And then find as much information as you can about this little right angled triangle. Draw a diagram if you need to, and make sure you know what you're trying to find. Okay, it's important to look at your horizontal lengths, okay? And look at your vertical lengths. So this plus this will give this full distance. Okay? This, which is this, plus this gives our full distance, okay? Hopefully that made sense. Yes, all right. I'll see you in the next video.